Okay, I'm going to make a video for Chapter 3. And Chapter 3 is mostly about numbers. Python has reduced its type of numbers to really two, int and float. Int is numbers without any decimal parts, and float can have decimals. A lot of languages have a whole lot more options than that, but Python keeps it simple. So I am going to, let's assign a value. I'm just going to say number 1 equals 34. And then what I'm going to do is I'm going to use a function that's built in. I'm going to say type and then number 1. And what it'll tell me is that it is an int, right? So that is a number without decimal parts. I'm going to do number 2 equals, let's do 45.2. If I do a type, number 2, you will see that there's a class float. So those are basically the two types of numbers. Okay, so I'm going to talk a little bit about the operators that you can use with these. We've covered some of them. So addition is obvious, so I'm going to do like this. I'm going to do addition. And addition uses the plus. So if I do total equals, I don't know, 53 plus 43, and then I do print total, it will show me a 96, right? And it would work with a float too. So I'm just going to do the same thing. 53.34 plus 43.2, and then print total. I'm using the same variable. What happens is that the second use overwrites the first. So it basically has, it's being reassigned at that point. So that's addition. So subtraction is just what you would think. It's a minus sign. So I'm just going to say 53.34 minus 43.2. Oh, and I need to assign it to something if I'm going to see it. So I'm going to say difference equals, and then what we'll do is we'll print the difference. Having trouble typing as always. So it doesn't, I spelled difference wrong. So I'm just going to say print, and I'm going to copy the first one which is misspelled. Okay, so 10 minus 4. Okay. Now, multiplication. Is an asterisk. So I'm just going to say the product equals, this time I'll just do 5 times 3. And if we print product, should be 15, which it is. Okay, and division is a slash. So So it's basically just this. And I'm going to say, let's say quotient equals, and we'll do 5 divided by 3. We can use this in a couple of ways. So if I print the quotient, it'll give me the decimals. Okay. Now, if we only wanted an integer, so integer division has 2 slashes, and what an integer division does is it doesn't give, so I'm going to say int quotient is equal 5, 3. All right, and it is going to, when I do print int quotient, so I didn't use the right division, notice. So I'm going to try to move this up a little, let's see. So I'm going to do the same thing, but with the proper 2 slashes. Okay, and then I will print it. And it will result in 1, because 3 only goes into 5 one time. To find the remainder, so I'm just going to call it remainder, equals, and what we'll do is we'll do 5% 3. All right, and if we print the remainder, need parentheses, we'll see that it has 2, because 5 goes into 3 once and has 2 remaining. So that's how you do, this is the difference between integer division, where it only returns, like in the 3rd grade, it returns how many times does 3 go into 5. And here returns the remainder. All right, so there's a couple of other operators I will show. Mostly, and then the percent sign here is for the remainder. The main thing I want to show you is there's also a sign for exponential. So I'm going to say expon. Let's just call it expon. Equals, let's say 5, and I'm going to do 2 asterisks, 3. So that'll be 5 to the 3rd power, right? And if I print expon, you'll see that it's 125. If I wanted to do it squared, just use the same variable, same numbers, except I will do 5 asterisk asterisk 2, so this should be 25. So we'll print expon, and we'll see that it is indeed 25. The book lists one more, which is more of a function than an operator. If you were to say, I'm just going to say num equals minus 25.3. Okay, if you use, I'm going to say num equals absolute minus 25.3. Or actually absolute, let's just say absolute num. And then we'll print num. And it takes off the minus sign. The absolute is just the number without any plus or minus. It's just the number as the number. Okay, so that is, those are all the different operators. So I didn't make comments for all of those, but they are. So there's the division, integer division, Integer division is the double slash. Remainder is the percent sign. Exponentials are two asterisks, and then absolute, which takes away, cuts, basically removes any minus signs from the number. Okay, a couple of other things I want to show you. Let's see if I can I move this up? If I move it up, it just wants to, I'm trying to make it so it's easier to see on the screen. But it's going to be a bit of a pain, I think. You can convert one kind of number to another. So let's just call it num3 equals 25.2345. All right. And then I'm going to say int num3. So we're casting a float to an int. And the result of that is that it becomes 25, right? It just drops the decimal parts. You can also cast an int to a float, but it doesn't really. So let's take num4, let's see, num4 equals 25, and we'll do float num4. So it makes it a 25 and it adds a 0.0 for the decimal part. There's one other thing I want to show you, and then we will do a problem. All right, so we will do, we still have number 3 up there. So it has 2, 3, 4, 5. There's another function that you can use, which is round. So I'm going to round num3. And remember, this is the one with all the decimal parts. If I round it just by itself, what it does is it takes it up to 25. I can also round num3, and I can say how far I want to round it. So I want to leave 2 decimal places. See how that does that? The second argument tells you how many decimal places. If you give it without any arguments, it just rounds it to the nearest whole number. So that's round. So we've gone through the operators, right? We've gone through plus, minus, times, division, integer division. We've done remainders. This is called the modulus, by the way. Exponentials, so raising it to a power. We've also cast an absolute, which just removes any minus signs. We've also cast a float to an int and an int to a float, and then we've used the round function. So those are basically, gives you a sense of what numbers are like. So I'm going to do the problem in the book where it basically lets you enter a certain how much change you got in your pocket and tells you what it's worth. So I am going to, just so that we're up at the top of this, I'm going to close this and do idle again, so it'll be up at the top. And then I'm going to do file, new file, and basically this program counts change, and then I would do like and then maybe the date, which is today, the 10th, the 1st of October. All right, so I'm going to do a def main, do a parentheses and a colon, and then see, notice the indentation again. I'm going to print a description of the program. Having trouble typing, as usual. Quotes there. All right. So this print is just to put in empty space. And then I'm going to print an instruction. You should always give some instructions. Please enter the amount of each kind, the count, wow, I'm bad at typing today, of each coin type. Okay, quotes. All right, so we're going to do quarters equals int. Okay, so int is the same as eval, except it will only allow integers. It will not allow you to have any decimal parts. And if you think about it, quarters always have to be whole. So do dimes. So we're going to use an int input dimes. Okay, and then we'll do nickels. We're assuming there's no 50-cent pieces, I guess. And then pennies. Okay, so we've put all of those in there, and what we're going to do is total equals 25 times quarters. This isn't actually your best way to do this. Plus, so and that should be 0.25, right? Because it's a part of a dollar. And then plus 0.10 times dimes. Okay, plus 0.05 times nickels. Plus 0.01 times pennies. All right, and then it has a print and a print. The total value of your change is okay, and that's the whole program. A couple things I may show you. These are not great ideas because they're like called magic numbers. Where do they come from? It would be better to declare them at the top, but we'll leave that as it is. So I'm going to save this. I'm going to save as, and I'm going to go to Documents, Python Files, and I'm going to call this change. So it'll be change.py, and I'm going to save it, and then we'll run it. Okay, so I'm going to say that there are 3 quarters, 2 dimes, 5 nickels, and 13 pennies. Whoa, what is it not like? Quarters is spelled different. What did I do for quarters? I did quarter. Let's change that to quarters and save it again. Alright, so if we run it now, so quarters will say same numbers, 3, 2, 5, 13. The total value is $1.33. Is that correct? I think it is. Okay, so that's a couple of things to note on that. This is an integer, but this is a float. Whenever you multiply or do a math problem with a float and an integer, it always resolves to a float. It always goes to the higher precision, and a float has higher precision than an integer. Okay. I also want to show you real quickly that there's a math library. So I'm going to go back to the interactive. I am going to import math. Importing is what you do when you want to add a library, and math is a built-in library. I'm not going to do much with this. I'm going to do, I'm just going to say root equals, let's just do math dot sqrt, so square root, and we'll just do 25. And that should give me, that should return print root, and it'll give me 5. Okay, there's a lot of different functions in math. I'm not going to do most of them right now, but I just wanted you to know that the math library exists. Okay, so the last thing I'm going to do is one more problem. So I'm going to do file, new file, and this one will be for the factorial because it has a couple of features. So we'll call it factorial.py. We'll say that it is a program to calculate the factorial of a number. And it also is an illustration, illustrates, I'm going from the book, for loop with an accumulator. Okay, so what we're going to do is we're going to do a def main again, colon, we'll print, so actually they just do in equals int input, please enter a whole number. Actually, that's okay. And then fact equals 1. All right, and then what we will do is we will for factor. Again, this is just in a variable in range. Now the range here is a little bit different. So n is the starting point. the 1 is the end point. And we're doing it by counting backwards, so we're doing it, the steps are -1. You can see in the IntelliSense here, this is the start, this is the stop, and these are the steps. So we're starting at whatever number we put in, we're stopping at 1, and we're counting backwards, okay, by ones. So a loop always has a colon, and it's another insert. So I'm going to say fact, which is 1, equals fact times factor. Now what that means is that for whatever number this is, this fact is going to change. It starts at 1, but we're going to take it fact times factor. So the first one will be, say we did the number 12. So the first one would be 1 times 12, so it would be 12. The next one would be 12 times 11, right? And then it would be whatever that number is times this. So anyway, so let's do the factor. Outside of the loop, this print is outside of the loop. Print the factorial of n is fact. Okay, the parts that aren't in quotes are variables here, right? So factorial refers to that, and fact refers to that. But mostly n refers to this, and fact refers to the fact. All right, so we call main. Okay, so let's run this. File, save first. I will call it, so I don't know why it always goes there. I want to go to Documents, Python Files. We'll call it factorial. Okay, now we'll run it. So I'm going to do a simple number like a 5, and the factorial of 5 is 120. Basically, a factorial is what is, if you break down a number into all of its individual elements, 1, 2, 3, 4, 5, what is the product of all those numbers? So if I run it again, let's do something a little, let's say 20, be a much bigger number, right? So it's a sum, 2. 2 times 2 is 4. 4 times 4 times whatever, 20 is 3, whatever, it keeps going. It breaks it all down into its numbers, and then it counts out. Alright, that's not a clear explanation, but I think that is enough for this chapter. So this is chapter 3, and I'm going to stop recording.